So for this problem, we are specifically using the limit definition of a derivative. Please make sure you pay attention to directions because if you just find the derivative using the power rule, I would not give you credit for this problem because I'm specifically testing not that you can find the derivative, which I know you can all use the power rule at this point. We kind of teach it backwards a little bit. But when I say using the limit definition of a derivative, I need to know that you understand what that limit definition is and how to simplify your limit. So there are three different definitions, limit definitions of a derivative, right? There's like Hannah's, and then there's like Hannah's, and then there's Anna's. And this Hannah's with the one H is the one I'm going to be using. But just to remind you, Hannah, hers is two H's. So she has the limit as h approaches 0 of f of x plus h minus f of x minus h over 2h. And then Anna uses n's. No, she uses a's. Sorry. That's the limit as x approaches a of f of x minus f of a over x minus a. So these are two other limit definitions, but I typically will use this one. The limit as h approaches 0 of f of x plus h minus f of x all over h. So just to remind you what this comes from, this is finding the slope between a point x and x plus h. For those points to be really close together so that you are finding the actual slope, then h needs to approach 0 so that these 2 points are really, really, really close together. And then this has a height of f of x. This is a height of f of x plus h. So if you were to use the slope formula, you get f of x plus h minus f of x over x plus h minus x. Your x's cancel in your denominator, so you just have h. All right, so let's go ahead and plug in what f of x plus h is. So f of x is x squared minus 3x. So f of x plus h would be x plus h squared minus 3 times x plus h. So that's my f of x plus h part, and then we need to subtract f of x, which is x squared minus 3x. Notice that I'm using enough parentheses here. Since you are subtracting f of x, make sure you put f of x in parentheses so that you don't make any mistakes with any negatives. Remember your rules for simplifying limits. Your limit does need to stick around. I suggest you work vertically so that you don't leave off a limit because that limit does need to be attached as you simplify. X plus h squared is x squared plus 2xh plus h squared. Make sure you distribute negative 3x minus 3h. Make sure you distribute the negative here, negative x squared plus 3x all over h. All right, a bunch of stuff should cancel, and if you are doing a problem like this and stuff is not canceling, then you are probably doing it wrong if it's just like a basic polynomial. If it's a polynomial, a bunch of stuff should cancel. If it was something like sine or cosine, then stuff would not cancel, and you'd have to use a different method. All right, so I noticed that 3x cancels and my x squareds cancel. So I have 2xh plus h squared minus 3h over h. I can divide out an h from all of these. Now remember, you are dividing it from every single piece, not just one piece. So that's going to be 2x plus h minus 3. Now I can plug in h as 0 because I have no denominator and I wouldn't be dividing by 0 if I plug in 0. So that would give me 2x minus 3. So that's the derivative. In fact, I'm actually going to write it as f prime of x is 2x plus 3. 2x minus 3. This is my slope function. It is my derivative. So you could use, since I have y equals x squared minus 3x here, I could also use the power rule just to double check. If I use the power rule, the 2 goes in front, x to the first, and then minus 3x, the derivative of that is just 3. So 2x minus 3, hey, it checks out. So that was 2x to the first. I'm just erasing it to make it more clear. So again, set it up always write the limit definition first, then plug in x plus h and x, then distribute, and then, use your proper limit notation as you solve until you get to the end. When you plug in h is 0, then you can just write your answer.